Welcome back, everyone. We're diving into something a little different this time, the golden ratio.
Ah,
It's
yes.
that mysterious 1.618, give or take, that's supposed to be like the key to beauty or something.
That's the one.
We've got some excerpts here, one from Wikipedia, and then this beginner's guide from Adobe.
Excellent sources.
Yeah, I think it'll be really interesting to see what they say. So what is the deal with this golden ratio anyway? Does it really live up to all the hype?
Well, that's what we're here to find out.
Right, okay, so it's not just a random number, right? It's a ratio.
A very specific ratio, yes.
Okay, explain it like I'm 5.
So you've got two numbers. If you add them together, and then the ratio of the bigger number to the smaller number is the same as the ratio of the sum to the bigger number.
Okay, I'm already lost.
No worries. It sounds complicated, but it's actually pretty elegant. You can represent it with this Greek letter phi, written as phi.
Okay, I've seen that symbol before. Phi, right.
Exactly. And get this, phi has this cool property where if you square it, it's the same as adding one to itself.
Wait, really? That's kind of wild.
It is. It's almost like a self-solving equation.
Okay, so how did this number, or I guess ratio, become such a big deal?
Well, it goes way back. Ancient Greece, to be exact. Mathematicians like Euclid were already studying it. They called it the extreme and mean ratio.
Extreme and mean ratio. That sounds kind of intense.
Well, they were really into geometry and perfect forms, and the golden ratio just fit right in with that, especially when you look at shapes like pentagons and pentagrams.
Right, those always look super intricate and symmetrical.
Exactly. The golden ratio is like their secret ingredient. And then there are these 3D shapes called platonic solids.
Platonic solids? Okay, you're going to have to explain that one.
So imagine a 3D shape where all the faces are the same regular polygon, like a cube, where every side is a square.
Okay, I got that.
Well, there are other platonic solids, more complex ones, like the dodecahedron, which has 12 pentagonal faces. And guess what?
Golden ratio is involved.
Bingo, it shows up in their proportions.
Wow, that's pretty amazing. Math can be beautiful, huh? Speaking of which, the Wikipedia article also mentioned this thing called the Fibonacci sequence.
Right. The Fibonacci sequence and the golden ratio are practically best friends.
I remember learning about that in school. So I'm thinking about bunnies.
Yeah, that's a common way to illustrate it. Basically, you start with 0 and 1, and each number is the sum of the two before it. 0, 1, 1, 2, 3, 5, 8, and so on.
Okay, that rings a bell. But how does that connect to the golden ratio?
As the sequence goes on, the ratio between two consecutive numbers gets closer and closer to, you guessed it, phi, the golden ratio.
No way. That's incredible.
It is, isn't it? And then there are these other numbers called Lucas numbers. They're like Fibonacci's cousins.
Lucas numbers.
They start with 2 and 1 instead of 0 and 1, but they follow the same rule of adding the two previous numbers.
So like a slightly different starting point.
Yep, and guess what? Their ratios also approach phi as you go further down the sequence.
So we have all these interconnected patterns that lead back to this one special number. That's pretty mind-blowing. It's like, it's not just an abstract idea.
Exactly. It pops up in so many unexpected places, like those golden rectangles we mentioned. They can be divided endlessly into a square and another smaller golden rectangle.
Wait, really?
Yep. And all those rectangles have sides in golden ratio proportion. It's a visual representation of this concept repeating itself at different scales.
So you're telling me this golden ratio might be hiding in plain sight in art and architecture all around us?
Well, that's where the debate comes in.
Ooh, a debate. Sounds juicy.
There are definitely cases where architects and artists intentionally use the golden ratio.
Okay, like who? Spill the tea.
Well, there's this architect, Le Corbusier, who developed a system called the modular.
Modular, what's that?
It's based on the golden ratio and human proportions. He used it to create these harmonious architectural designs. Villa Stein at Garches is a great example.
Wow, that's fascinating.
And then there's Salvador Dali.
Dali, as in melting clocks Dali.
The one and only. Always a fan of the dramatic, he actually incorporated a giant dodecahedron into his painting, The Sacrament of the Last Supper. And remember, the dodecahedron has those golden ratio proportions.
Of course. That's so cool. And even the flag of Togo, according to this Adobe article, was designed using the golden ratio.
It's a surprisingly versatile concept, but here's the thing. While there are these clear examples of intentional use, there are also a lot of claims about the golden ratio being present in famous works of art and architecture that are a bit more iffy.
Iffy how?
Well, some people claim that famous works like the Mona Lisa or the Parthenon are full of golden rectangles.
Okay, yeah, I've heard that before.
But when you actually look at the measurements, things get a little shaky. Sometimes the proportions are close to 5, but does that really mean the artist or architect intended it?
That's a good point. It could just be a coincidence, right?
Exactly, and maybe our brains are just wired to find patterns, so we see the golden ratio even where it doesn't actually exist.
It's like those optical illusions, where you see one thing, but it's actually something else entirely.
It's very similar, so while the golden ratio is definitely a fascinating concept, we have to be careful not to overstate its importance.
So it might not be the universal key to beauty after all.
Well, it's definitely more complex than that, and that's what makes it so interesting to explore.
I'm definitely intrigued. It seems like we've only just scratched the surface.
Oh, absolutely. There's so much more to uncover. You know, it's funny how one number can cause so much debate.
Yeah, it's like we're on this treasure hunt for meaning, but the treasure might be a mirage.
It's all part of the fun, though, right? Trying to figure out what's real and what's just our brains playing tricks on us. Speaking of unexpected places, the Wikipedia article mentioned something about the golden ratio in financial markets.
Wait, what? The stock market?
Yep. Apparently, some financial analysts believe the golden ratio can predict stock market movements.
Okay, now you've got my attention. How does that even work?
They use it to identify these things called support and resistance levels.
Support and resistance levels.
They're basically price points where a stock might change direction. Like if a stock is going up, a resistance level would be a price where it might start to fall.
Okay, I kind of get that. But where does the golden ratio come in?
They use these things called Fibonacci retracement levels, which are based on, you guessed it, the Fibonacci sequence.
Oh, right. So they're looking for echoes of the golden ratio in the stock market.
Exactly. The idea is that after a big price move, a stock will retrace a certain percentage of that move before continuing in the original direction.
Okay, so how do they use the Fibonacci sequence for that?
Well, those retracement percentages are often derived from ratios within the Fibonacci sequence itself.
That's pretty wild. But is there any actual evidence that this works?
That's the tricky part. Some traders swear by it, but there's no concrete proof that it's foolproof. A lot of it comes down to market psychology.
Right, because if enough people believe in a pattern, they might start trading based on it, which could actually make that pattern come true.
It's a self-fulfilling prophecy.
It's like we were saying earlier about how people perceive beauty. Sometimes we see what we want to see.
It all comes back to the importance of critical thinking. We can't just blindly accept any pattern or theory. We have to question our assumptions and look for solid evidence.
Yeah, otherwise we're just chasing shadows, right?
Exactly. It's a balance between appreciating the beauty of a concept like the golden ratio while also staying grounded in reality.
So back to the golden ratio itself. We've seen how it's captivated people for centuries, but a lot of the claims about its influence seem to be, well, questionable at best.
It's a mixed bag for sure, but that's what makes it so fascinating, right?
Yeah, I guess the journey is more interesting than the destination sometimes. So what's next on our golden ratio adventure?
Well, we still haven't explored the golden ratio in nature. That's always a popular topic.
Oh, yeah, that's right. Like seashells and flowers and stuff. I'm excited to dive into that.
Let's see what wonders await us in the natural world.
Okay, so the golden ratio in nature. This is the part I've been really curious about.
Yeah, it's definitely one of the most captivating aspects of this whole golden ratio thing.
It's just this idea that math, like this very specific number, is woven into the fabric of nature. It's kind of poetic, you know?
I get it. It's definitely appealing. But as with a lot of things related to the golden ratio, we have to be careful not to get too carried away.
Right, right. Always good to have a healthy dose of skepticism.
Hmm.
So where should we start? I know the Adobe article mentioned something about spiral arrangements in plants.
Yeah, like the arrangement of leaves and seeds. Those often follow a pattern based on the golden angle, which is about 137.5 degrees.
Okay, the golden angle. And that's connected to the golden ratio.
You bet. And it makes sense from a practical standpoint. Imagine a plant trying to get as much sunlight as possible. If the leaves or seeds just sprouted randomly, some would end up blocking the light for others.
Oh, that's true. I never thought of it that way.
But if they follow this golden angle pattern, they can spread out more evenly, making sure everyone gets a fair share of sunshine.
It's like nature's way of being efficient, huh?
Exactly. It's all about optimization.
Pretty cool. So what about other examples, like seashells? I've always heard those were a classic example of the golden ratio in nature.
The nautilus shell. It's a common misconception, but those aren't actually golden spirals.
Wait, really?
They're close, but not quite. Their growth pattern is more of a logarithmic spiral. It expands at a constant rate, which is different from the golden spiral.
So another case of close but no cigar.
Pretty much. And it kind of highlights a bigger point. Nature is incredibly complex. To say that the golden ratio is the sole explanation for these patterns is an oversimplification.
Yeah, that makes sense. There are probably tons of factors involved.
Absolutely. The golden ratio might play a role sometimes, but it's not the only answer.
It's almost like our brains are looking for it, So we see it even when it's not really there.
We do love our patterns, don't we?
We do, but it's important to acknowledge that, I guess, to not force the golden ratio into every situation.
Definitely. But even with that said, the fact that this mathematical concept keeps popping up in nature, even if it's not always perfect or precise, is still pretty remarkable.
It's like it suggests some underlying connection, some kind of harmony between math and the natural world.
Right. And I think that's what continues to fascinate people about the golden ratio. It's a reminder that there's still so much mystery and wonder out there.
It's a good reminder to stay curious, to not take things for granted.
I couldn't agree more.
So as we wrap up our deep dive into the golden ratio, what are some key things you want our listeners to take away from all this?
Well, first and foremost, always be critical. Question assumptions. Look for evidence. Don't just buy into hype, no matter how alluring it might seem.
Solid advice for life in general, really.
Absolutely. But beyond that, I hope this has ignited a spark of curiosity. Even if the golden ratio isn't some magical formula for beauty or success, it's a fantastic way to view the world, to see the connections between things.
It makes you appreciate the elegance of math and the intricate patterns that exist all around us.
Exactly. And who knows, maybe this will inspire someone listening to go out and explore the world with a fresh perspective, to look for the golden ratio in unexpected places, or maybe just to appreciate the beauty of nature and art a little bit more.
Well said. That's what we hope for with every deep dive, to encourage people to think, to question, and to keep learning.
To embrace curiosity and keep those minds open to new possibilities.
Couldn't have said it better myself. So to all our listeners out there, thanks for joining us on this deep dive into the world of the golden ratio. We'll see you next time.
Until then, keep exploring.